Hey, what's up, guys? Welcome to my YouTube video. And yeah, so welcome to my algebra geometry. So previously we talked about the home functor. So this one should be what? Talk about a tensor, right? Tensor. So we will prove the tensor product is right exact. Okay, so before we start that, I should give you some background, right? So the setting is that so we're taking the commutative ring and AB will be R module. Okay, so the question is that what is, so I think this, everybody knows this, but let me just quickly remind. So how to define this in tensor B? So it's very easy that you can define it to be all a tuple, right? So basically all a tuple AB, where A belongs to A and B belongs to B, quotient some relation. So the simple relation is that they are all like linear, right, in both coordinates. And then there are all, if you times R, A, B will be R, A, B, and A, R, B. Okay, so this is the, and then one can check this guy is the, will be the tensor module. Okay, R module. Okay, yeah, and so fact is that the tensor product is right exact. Okay, so I will use a fact that, proof in the future, but this guy is, okay. So there is an idea called adjunction. So basically, if you take Rx and home of Rx, these are at a junction to each other. Okay, so let me just quickly say what is the okay, so let me just so we will use the fact that your home of, let's say, to R from M and home of Rxp will isomorphic to the home of R M tensor X R P. Okay, so this proof, simple proof is that if you imagine that MXP are all vector space, that should be easy for you to prove. Okay, so this guy's not so difficult. And also, let me just quickly, right. So the idea is that if we, what I'm saying is that if we have exact sequence, then tensor product is right exact. So basically, it means that you always have this AR and the M of BR and the M of CR goes to 0. And the map is basically, if this is phi and the psi, the map is just, right? So the first one will be identity. So you get just identity tensor with phi and identity tensor with psi. Okay. So simple y, so y not left exact. There is a simple example. If you learn the algebraic topology, then this example should not be difficult for you. So if you start from z, where you go to z, where you go to z2, z is 0, right? It's times 2 here. Okay, so you can see this map. Hopefully this is correct. So, right, so image. So this, by the way, right, so obviously that is exact because in this part, this guy is injective. And this, right, this guy is injective, right? Because any two, right, 2A equals to B, A must equal to B. Okay, and this map is surjective. And also anything which map to 0 by definition come from the right left hand side. So we can like tensor z2. Okay, if we tensor z2, then we get z2, right? So there is a fact that right. So there is a fact that if you tensor with z, so now we view everything as z module. Basically, it's the same as abelian group. Will always be z2. Okay, so you get z2, z2. And then this is, and wherever here, right? So we can check wherever here. Okay, and but now this map becomes 0, right? So this map is not injective. Right, so now you will lose the exactness from this part. And obviously you can check this part still exact. Okay. Okay, so let's go to the proof. So the tool what we use is that the home is left exact and the tensor is right, and we need to prove that tensor is right exact. Okay, so yeah, okay, so they're very simple that we start from ABC equals to 0, proof, and then now we start to right, so we can take home, right? So let's say we take home of go to P. Previously, I think previous video I proved this guy is left exact, so this guy will this guy will be right exact. So this is left. This should be right. Oh, sorry. Sorry. I'm stupid. So previously, I think I proved. Yeah, this guy should be left exact. Now, oh yeah, so this guy is yeah, so this guy is like just the reverse of this guy, right? So you need to like flip this sequence, right? Because now if you do this, then you C map to B will induce, right? Now you have this, right? C map to B, now you have B and A, right? So C map to B will can be induced from B to P and A to B. So you must have the following. So home of using the same proof, home CP, home BP, and home AP. Okay, so this is from previous one. Now with this way we apply the tensor, so we can apply M of not really. Let's apply another map. Okay, so we get okay, so we get the following. We got 0, home of M, home of CP, and home of now this guy, right, as previous proof is left exact. So we have home of home BP and home of M, home of AP. Okay, now we use this property. So we have M and XP you can tensor this, right? Okay, so you get the home of M tensor C P, home of and tensor B P, and the home of and tensor AP. Okay, so notice that this exact sequence is true for every P. Okay, so now we need a lemma, right? We need to say something to remove this home. Okay, so this lemma tell you that if we have home of CP, home of BP, home of AP goes to 0, and then let's say this map is induced called psi star. This is phi star, and so this sequence can come from A phi B psi. Okay, so what I'm saying is that if this guy if this guy is exact for every P, then this guy will be exact. So the lemma says that if this is exact, then this guy will be exact. Right? Okay, suppose we have this, then we can remove home. Right? And finish the proof. Okay. Okay, so goal is just to finish this, right? Okay, so let's go to a proof. Okay, so right, in order to do this, we need to show that we need to show the same thing, right? We need to show that we need to show that the image of phi star is the same as kernel psi star is the same as kernel phi star. Okay, so one direction should be simple. So let's take since P can be everything, right? So let's take P to be C. Okay, so if I take P to be C, then this home CC, and I can right. So right, let's take P to be C, and then so let me just write down this diagram. So I have A B C, right, and say P. I take this to be C and take identity map. Okay, so if I do this, then by definition, then I have phi star psi star identity C. Okay, and then this is the same as phi and composite with phi. Okay, right, because this is phi and the psi, right? So you have this, right? So you compose it with phi echelon identity, and you use phi, right? So you first act on phi and then go to psi, because now this map, right? This map give you this map identity here goes here and go here, and in this case, right? In this map that we are going to do is that we start from here, right? So if I composite twice, right, then then I should get what, right? So this is 0, right? Right, because this guy is x, right? So I start from here and then go here, go here. Okay, then but by definition, this is the same as composite with phi and psi and phi. Okay. Right, because this map, right? This map is just first go psi and identity, and then this map I go to identity, go psi and go phi. Okay, so this guy is 0 due to this exactness. Okay, so due to exactness, so this gives me the kernel of psi will cover the image of phi. Why this so difficult? Okay, so now next that we should take is we can take P to be the cokernel. So this is interesting cokernel phi. Okay, so I take B to be cokernel. I take P to be cokernel phi. Okay, so now let's see what we have. Right, we still have A and B and C. Okay, and now I have B to the cokernel phi. So I have phi here and psi here, and then now B could be cokernel phi. Okay, now this map, right? So this map is like this map just the surjection, right? Okay. Okay. So now let's take, so we can take phi star. Let's say we take phi star H. Okay. So what's phi star H? So let's go back, right? So phi star is here, right? So phi star H. Okay, so is that phi star H is that we start any map B to P that I map to A to P. Okay, so this H, right? So I should take what? I should take phi H, right? Composite with phi by definition. And what is this? 0, right? By definition, right? Because any guy which map to phi will be image of phi, right? And the B map in the cokernel by definition 0. Okay. Now we have the exactness, right? Because now H belongs to the kernel of phi star, right? Will be the image of psi star, right? By the exactness. So now we have some guy, right? We have some here, some guy which called H prime, right? Here, such that this diagram compute. Okay. Okay, but then this just tell me that if you do the H prime circle with psi, right? Your H prime circle with psi, right? Will compute with will give you H. Okay, so this gives you what? Okay, so this gives you what? This gives you that the kernel phi, the kernel psi, right? Kernel psi will inside the kernel H. Okay. Obviously this is true, right? Because if psi is 0, then H will be 0. Okay, but kernel H will be image phi. Right? By definition, this is the definition, right? This is the first isomorphism theorem. So B map to B quotients B map to the cokernel, right? So the kernel will be just the image. Okay. Okay. So now what we have shown is that kernel psi is the subset of kernel H, and it's an image phi. Okay. Yeah, so this basically proves our results, right? Because we start from because we start from something, right? We start from, let's see. So we need to prove, right? Right? Yeah, exactly, right? We need to prove that kernel psi is in the image phi. Okay. So now we take the kernel psi, right? So we have proved that kernel psi is the subset of kernel H, where is image phi. Okay, exactly is what we need for another direction. Yeah, so this is the proof of tensors, right, Exact? Okay, and at least at the junction, I think you can use the same linear algebra proof as vector space. Just write down the detail. Okay, so see you guys next videos. Hope you guys subscribe to my channel.